All right, so this is where we left off on Monday. So what did we talk about on Monday? Anybody remember? Anybody look back? Who looks at your notes between classes?
Talk about temperature.
Talk about temperature. What else? Chemical and physical changes. Calories. Talked about how to do calculations with food. Figure out how many calories are in there, right? So, and I said we're going to stop. I said we're going to stop there, and we're going to start on this section because there's a lot of calculations in the next section. I didn't want to go on because I figured it would confuse the issue, right? So, this next section is called specific heat. Anybody remember about heat? What is heat?
Energy.
Heat is a form of energy. Can you hold heat in your hand?
No.
You cannot, because it is not matter, right? So heat gets transferred from one thing to another, doesn't it? Like I can give you heat. I actually can't because we both have the same amount of heat. Well, actually I have more heat than you do. Why do I have more heat than you? Our body temperatures are the same, roughly, right? Why do I have more heat than you?
Because you're a man.
I have more mass. The more mass you have at the same temperature, the more heat you have. And we're going to talk about that today. We're going to show how that works, okay? So specific heat is a measure. One way to define specific heat is it's a number that's given to every object or to every type of compound for how easy it is to heat it up or cool it down, okay? Some things are really hard to heat up. It takes a lot of heat to change the temperature. Some things are easy to heat up. It doesn't take much heat. They would have a low specific heat versus a high specific heat for something that's hard to heat up. Fair enough? The actual definition for specific heat is the amount of heat it takes to change the temperature of 1 gram of a substance 1 degree Celsius. Okay? So if you had 1 gram and you want to change the temperature of 1 degree Celsius, how much heat would you have to put into it? And what are the units on heat? Joules or
Calories.
little c calories, right? Joules or little c calories. So this equation, I'll rewrite it. We're going to have two equations today. Specific heat equals heat over mass times change in temperature. When you see that term delta, it means change. Okay? So here we have specific heat equals the amount of heat divided by the mass times the change in temperature. Now I can rearrange this equation, and I learned in the other class they don't really understand about rearranging equations. This is another equation that you might need. It's really this equation is rearranged. E. So this equation is what is the specific heat, okay, for a given substance. This equation right here describes how much heat does it take to heat something up. Why does it take more to heat me up than does it heat you up? Look at the equation. Do we have the same specific heat?
No.
Yeah, we're both made of what? Mostly water. We're both mostly water. We start at the same temperature, and I'm going to heat you up 5 degrees. I'm going to heat me up 5 degrees. It takes more heat to heat me up. Why? Because I have a bigger mass. I.e., when you go to cook dinner, and you put a little tiny pot on the stove with a little bit of water in it, and you put this burner on high, how fast does it heat up? Pretty fast. But you put the big pot on there because you're going to boil some pasta. Takes a while, doesn't it? Why? More mass. They have the same specific heat. They both heat at the same, they both absorb heat at the same amount of time. You want to change the temperature the same amount, but one of them is bigger than the other one. Okay? By the same token, let's say that you wanted to heat up some water, but for some reason you also want to heat up some alcohol. You use the exact same amount of both, 100 grams. And you want to change the temperature from 25 Celsius to 75 Celsius. Which one would heat up more quickly? What do you think? You think the alcohol would heat up more quickly or the water?
Yeah.
Why? They both are 100 grams.
Molecules. They release quickly, separate.
Look at the equation. What's different between water and alcohol? The specific heat would be different. Alcohol will absorb the heat much more rapidly than water does. Water has a relatively high specific heat. Alcohol would have a low specific heat, okay? So it heats up quickly. Any of you ladies ever spill acetone on your hands when you're cleaning your nail polish off? What does it feel like?
Cool.
It feels really cold. Why? Because the acetone absorbs the heat really fast. Water doesn't feel that cool on your hand, does it? If you spill some water on it, no, it feels a lot different. It has to do with the heat transfer. Acetone takes the heat really rapidly. Okay? Two equations. It's actually the same equation rearranged. Okay? We're going to use both of them today to do calculations. Okay? Here's some examples of specific heat. Note there are two columns here because the units of heat can either be calories or joules. The two columns are the same, they've just been converted from one to the other, right? Anybody remember the conversion from calories to joules? Very good. 4.184 joules equals 1 calorie. Okay? So the specific heat for aluminum is only 0.214 calories per gram versus 0.897 joules. Note that most metals have a pretty low specific heat. Anybody ever heated any metal before?
Yeah.
Where'd you heat metal at?
Welding.
Oh wow, that is fancy. I'm talking about every day. I don't weld every day. Holy cow.
Don't mess with her.
Anybody ever heat any metals? Anybody heat metal on a daily basis? I do. Cooking, right? Look at the specific heat for most metals. Pretty low. Water is down here with a specific heat of 1 calorie per gram. Anybody have any cast iron pots?
Yes, love it.
Look at the specific heat for iron. 0.1 versus 1 for water. What does that mean? It means the pot heats up real rapidly and it easily transfers the heat to the water, doesn't it? Okay? Make sense? A little bit? All right. Moving on along. Might need that table. So, first question. We got to think a little bit. When the ocean cools, what happens to the air around it? All right. I know I always have to explain this one. What does it mean that the ocean is cooling? What's happening to the ocean if it's getting cold?
Losing heat.
It is losing heat. We're talking about heat, right?
Yeah.
In order to get cooler, you gotta lose heat. Temperature go down, you gotta lose heat. Well, if you're losing heat, that heat's gotta go somewhere, doesn't it? Where's it gonna go? Surrounding air. So surrounding air does what when the ocean cools? It gets warmer. Because there's a limited amount of heat and it just gets moved back and forth. Okay? Sand in the desert is hot in the day and cool at night. Sand must have a high or low specific heat?
Low.
Low. It's easy to heat up. It's easy to give up its heat. Has a low specific heat. If it had a high specific heat, it'd be really hard to heat it up, wouldn't it?
Mm-hmm.
It's not hard. Okay. That's why. Anybody ever been to the desert?
My dad.
We go to Las Vegas. Go gambling. It's hot during the day. And it feels cold at night because there's a big temperature difference between day and night. Always in the desert, it's like that. Okay? Because sand has very low specific heat. Now, here's that other equation that I put up there a minute ago. Look right here. Heat equals mass times the temperature change, that's delta T, times specific heat. Now look at the units on it. Let's look right here. Let's look at this row right here. If I want heat in calories, mass is always in grams, right? Change in temperature is what? Degrees C. And look at the units on specific heat. It has 3 units. Calories per gram degree C, or it could be joules per gram degree C if you want your answer in joules. Okay? However you want your answer, that's how you want to look up your specific heat in that table that we showed a minute ago. Either calories or joules per gram degree C. Okay? Mass is always in grams, and temperatures in degrees C.
Why is everything crossed out? Like, why are there so many?
The units?
Yeah.
They're just showing how the units cancel, and you're left with calories. Grams cancels here, degree C cancels, and you're left with joules. That's all they're trying to show.
Okay.
So, I'll let you guys work on this one for a minute while I find a sign-in sheet.
The calories and joules are the same.
They're the same type of unit. They're both units of heat, and you can convert from one to the other using the conversion. 4.184 joules equals 1 calorie. So if it asks for it in 1 unit, you do the other one, you just convert back to the other one. Remember I gave you 2 equations earlier, right? You want me to write both equations up here again? You got to use one or the other of these. All right, let's take a look at it. So when I look at a problem like this, how do we attack this problem?